Okay, I'll just start that one again. Alright, so in matrix algebra, whenever it refers to the operational things that you do, the matrix is normally given in bold. Okay, and then if you're going to do some other matrix, okay, the matrix is in bold. And then some other matrix, the matrix is in bold. So you get to learn about what to do at this level, but at the meta level, it's just probably more important that you understand what's happening with the matrix algebra, because it follows certain rules. So what we can do is augment an equation, and the one in the tutorial for tutorial 3 is the current equation, and so I'll just write it the way it's got it. No. Okay, so the first thing that I would get you to do is to augment. So how do we generate this system of equations? And it's really quite rude, because it means we've got to do row down column multiplication. So what we're going to do is take the easy stuff, which is the coefficients. So we get 1, 1, 1 minus, now be careful, because that's 1 and that's 2, but there's no 3. So we've got a minus 2 for the first row column, a 3 for the second column, and the third column is 0. Just looking at that left hand set. I1's missing, so it's a 0. Then we've got minus 3, and then we've got plus 6. So that's our augmented set for the left hand side. Now what about the variables? The variables go down like this. Okay, now if we do a row down column, row down column, row down column, we will get the left hand side. Do you see how that worked? We did a multiplication, row down column, row down column, row down column, and we got the left hand side of the equation set. On the right hand side, the equation set is just listed that way. Now this is a classic kind of problem. So what they're looking to get you to do is to find these guys. These are the unknowns. In other words, these are your equations. Now from a matrix algebra point of view, the way that we would normally do this is that we would use matrix algebra to work this through. Okay, so to solve for x, we would need to use the rules. What you do to one side, you do to the other. So if we put that on the left, it had to be on the left over here. This is the identity matrix. The inverse is on the left. So that's what we're about. We're solving for x. Now there's a couple of different ways to solve for x, and I pointed those out. One of them is to do a row reduction, and the row reduction technique occurs in a couple of different ways, not unlike what I did before, and we can row reduce all the way down in echelon form, and we can use a cofactor method, and in the particular tute it said use Cramer's rule. So what I'm happy to do, I'm happy to just sit here with you and work through this, okay, so that you can see each of the methods being operated on. Alright, so let's do the matrix invert. 1, 1, 1. minus 230 0 minus 3 6. Okay, so whether I bring in the constants and start treating it like an equation like I did before, so what I'm going to do here is put the identity matrix, and we're going to start doing row operations. Now what we want to do is we want to move all of this over here to this side. Okay, and so what we've got is a 0, so that's okay. We've got a 0 there, so that's okay. So we need to target our next one. Okay, so what I want to do is I want to make that guy a 0. And now I'm pick that one because in your rules that you read about matrix operations, we do the columns before we do the rows. So this is the one that I'm targeting, and that's a process. That's a step that you have to follow. So row 2 is going to become row 2 plus 2 times row 1. So we're going to get minus 2 plus 2 ones, which is minus 2 plus 2, which is 0. Tick. So we're only operating on row 2 at the moment. And look at what you've got to do. Have you got to do this for all of them? Yeah, baby. Are you serious? Can't we use technology? Well, you can, but not now. 3 plus 2 ones. 0 plus 2 ones. That's so you don't make a mistake, right? Because if you make a mistake, you have to go and do it all again. 0, keep going, plus 2 times 1. 1 plus 2 times 0. 0 plus 2 times 0. So that's our first step. Okay, the next thing we want to do is target this one. So we're doing the next one below the previous 0. Okay, so we've got to do row 3 operations. Now this is going to be a bit awkward because it's got, we can't do the top one, we can't do row 1 again because we'll pull a 1 down here. So we've got to do row 2. This is part of the reason you follow a procedure. So before I do that, I might simplify this middle row one more time just by dividing by 5. Row 2. So it'll be 1, 1, 1, 0, 1, 2 on 5, 2 on 5, 1 on 5, 0, 0, minus 3, 6, 0, 0, 1. So what I've done there is I've made it that I can target this one easily. So row 3 is going to become row 3 plus 3 lots of row 1. So you can see it won't affect the first one, so that's 0. 0 plus, no, row 2. 3 lots of row 2, which is 0. 0 plus 0, which equals 0. Okay, for the next one, minus 3 plus 3, that's the one we wanted. Minus 3 plus 3 is equal to 0. So now we've made that second one a 0. As a consequence, we've got to keep going. 2/5, 6 on 5th. So we've got to change that to 5s. 36 on 5. And we've got to do the next one. 0 plus 3 2/5. So that'll be 6 on 5. 0 plus 3 1/5. That'll be 3/5. And 1 plus 3 noughts will be just 1. Okay, so there's a little bit of work to do to get all of this stuff kind of sorted out. Okay, so with the last row, what I can do now is I can multiply and divide in one hit. I can multiply by 5 and divide by 36, and that'll simplify this row. That'll be 0 0 1. Then we've got cancel 1/6, cancel 3 3 36 1 1/12, and 5 times 36. 0 1 2/5. So you can see that for some of them it's quite laborious. This is the drudgery. Look, if you become experts in this, unfortunately it's only 1 week. If you'll visit it again in Mathematics 2. There's actually a subject called linear algebra. It's very hard for me to convince you of the merit of getting into this, but it's the answer. If you want to model your world, you're going to end up using matrices. So understanding how you use them from the subject, passing the subject point of view, and how you use them in the career, there's a bit of disparate interpretation there. So I just encourage you to keep thinking about it. Alright, so the next one we want to do is probably target this one here and make that a 0. So how do we do that? We're going to subtract row 1, take away row 2 by the look of it. So we'll get 1 0 1 minus 2/5. 3/5. 1 minus 2/5. Again 3/5. Minus 1/5 and 0. Okay. So the next thing we'll do is we'll target either one of these two, but I think it's this one. And we'll use row 3 because that means we won't be adding anything to this left hand side. So it'll be row 2 subtract 2/5 row 3. 2/5 minus 2/5 is 0. So that'll work brilliantly. So 0 minus 2/5 of 0 is 0. 1 minus 2/5 of 0 is 0. 2/5 minus 2/5 is 0. 2/5 minus 2/5 minus 2/5 of row 3. Dun dun. So it's 2/5 minus 2/30. So it's going to be 6, isn't it? 6 5s are 30. 12 minus 2 is 10 on 30. 1/3. So that wasn't too bad. 1/3. 1/5 minus 2/5 of 1/12. So that's 1/5 minus 2/5 of 1/12 is 1/5 minus 2 over 60. So 12. 12 minus 2 is 10 over 60, which is 1/6. Look, they always come out if you're prepared to be patient. And finally we get 0 minus 2/5 of 5/36. Well, that's a cancel, isn't it? And 2/36. We'll just leave that like that. 2/36. So that was our row 2. This is the drudgery of the course at the moment. So yeah, if you're being patient, you're still with me, you're doing very, very well. Okay, the final thing we want to do is subtract 3/5 from 3/5 of row 3. So we're going to do row 3, row 1 is going to become row 1 minus 3/5 of row 3. So for our first row, 1 minus 3/5 of 0 is 1. 0 minus 3/5 of 0 is 0. 3/5 minus 3/5 of 1 is 3/5 minus 3/5, which is 0. This is where it'll get to be fun now. 3/5 minus 3/5 of 1/6 is going to be 3/5 minus 3 on 30. It's going to be 6, so 6 3s are 18. 18 minus 3 is 15 on 30, which is a half. Minus, sorry, is that 1/5 or minus 1/5? Minus 1/5 minus 3/5 of 1/12 is minus 1/5 minus 3 over 60. So it's going to be minus 12. So it's going to be minus 15 over 60, which is minus 1/4. And finally it's going to be 0 minus 3/5 of 5/36. So once 3 goes into that 12 times, so minus 1/12. And that's our inverse. Okay, so that's a to the minus 1 there. Okay, now always we're using technology. Can you do it for this one as well? Yep. So we're finding sorry, it's going to be, okay, so this will be a bit of fun. Row, column, row, new row, comma 3, comma 0, new row, 0, comma minus 3, comma 6. Let's have a look at that. Does that look like our candidate? Is that the same matrix that we had at the beginning? 1 1 1 minus 2 3 0 0 minus 3 6. Awesome. Okay, now no good doing this in a test. And 136, 18 is a half, 4 nines are 36 minus a quarter, 3 minus a 12th, 1236 is a third, 636 is 1/6, 2 minus 236. I might have made a mistake there. That looks like it should have been a minus, but I'll have a look at that. 1/6, 636, 1/12, 3/12 is 36, 5/36. So that looks good. So I've been able to do that. That's got us the long way, so at least as good as technology. So that was our first method of getting the inverse. Now to solve it, all you would do is multiply that by b. Okay, so you would multiply all of that, taking out the 36, which was clever, which I of course didn't do, is multiply all of that. Let's just shrink this down a little bit. 18. And we're going to multiply that by b, which was, okay, and so we go row down column. So if we do 1 on 36, we'll go row down column, so it'll be minus 9 times 24, whatever that is. And then the row down column, same again, 6 by 24. Then row down column, 3 by 24. So we're only taking the middle ones because it's 0, 0. Okay? So we can do that simply by doing a times, make a column 0, comma, oops, comma, new row 24, change it, comma, new row 0, close it, close it. So that should be the inverse times the column vector, which is 0, 24, 0, and so we get the results that we were looking for. Okay, which is minus 6, 4, and 2. Okay, so that'll give you the correct answers if you do it that way. Alright, so is there any questions about that model? Are you happy with how we progress that? Belligerent, difficult, laborious? I know. Do you want to be an expert or do you want to be a bum? Excuse the language. That's the idea. Alright, now the next one we looked at was, we'll do the same one with the cofactors. Okay, so I'll do the same thing with the cofactor method. Alright. Okay. Okay. Alright, now for the cofactor method, what's the difference between a determinant and a cofactor method? There is only one difference. And for the cofactor method, you have to do all of the points. So if you do the first one, you'll have 1 1 this time for the determinant, if I'm just going to do these and exaggerate them. So what we would have is 1 times minus 1 to the power 1 plus 1 is 2 times this guy here, 3, 0, minus 3, 6. Now, if you do that for the determinant, this is included in the determinant. So you still do the other bits, but you don't do the actual thing. Okay? So for our cofactor, that doesn't get included. This part does. Alright? Now the next thing we'll do then, instead of yeah, I'll do them in blue. Sorry, I'm just thinking about how to present this because it sometimes gets a bit messy. So I'm just thinking I'll put this up here. I'll have another blank. Okay, so what we're going to do is we're going to make up a big cofactor method with all of the submatrices in it. And the submatrices are going to be these guys. So the next one we'll have here is 1, 1, 1. It's that one. So it'll be not that minus 1, but minus 1, row 1, column 2, times minus 2. Okay, and then we'll have it again. Okay, and this time we'll be going down that way. So we'll have minus 1, row 1, column 3, which is 4, times minus 2, 3, 0, minus 3. And each of these go in here. So this is 3, 0, minus 3, 6, minus 2, 0, 0, 6, minus 2, 3, 0, minus 3. Okay, and then what have we got? We've got 1, we've got negative 1, and 1. Now they are not the placeholders. Coincidentally, they're the placeholders, but down here we're going to go again. Okay, we're going to go 1, 1, 1, minus 2, 3, 0, 0, minus 3, 6, and now we're going to the t. But we're not including the minus 2 this time. We're just going to do minus 1, row 2, column 1, 2, 1 is 3. So that will be a minus, and the submatrix will be 1, 1, minus 3, 6. So this one here will be negative 1 because it's an odd. Then we'll have 1, 1, minus 3, 6. Okay? And then we'll do it again for the middle one. 1, 1, 1. But we won't take the placeholder, only its address, which is 2, 2, which is 4, and its submatrix. So it'll be a positive. Okay, and you go through and do that for all of them. Okay, do you get the idea? Okay, so what I'm going to do is I'm going to try and do it without error. So this one here will be the end one, so it'll be minus 2, 3, 0, minus 3. And because it's 2, 3, it's 5, so it'll be a negative 1. Okay, this one down here is there, so it'll be 1, 1, 3, 0. And because it's 3, 1, it's an odd, it's an even. 3, 1 is 4. The middle t at the bottom will give you 1, 1, minus 2, 0. Middle t at the bottom is 3, 2, which is an odd, so it'll be minus 1. Now, I know that some teachers will teach you this. No. Okay, don't do that. Use the address method. Okay, use the address method. Okay, and then the final corner, 6, 1, 1, minus 2, 3. And because it's 3, 3, that's an even, so it'll be a 1. So we'll end up with a cofactor matrix. A cofactor set. Now what have we got? 1 outside of 3 times 6 minus 3 times 0. That's gone because it's a 0. So we're going to get 3 6s, we're going to get 18. Okay, so this one here is negative 1 outside of minus 2 times 6 minus 0, so that's ridiculous. This is going to be a plus because it's minus 12 times minus 1 is plus 12. Then we're going to have 1 outside of minus 2 times minus 3. Minus times a minus is a plus. That's 0 times 3, so that's gone. Minus times minus is a plus, so that's 6. Minus 1 outside of 1 times 6 minus 3 times 1. So we get minus 3, so it'll be plus, so 9, minus 9 overall. This is starting to fit the pattern of the, if you look at these numbers and you look at our, it's starting to fit the pattern of the previous one. Alright, it's starting to fit that pattern. Okay. Alright, 6, I think that's 6. Minus times minus 6, minus 6, 0, minus 3, 0, minus 2. Be careful. So that's minus 2 minus 0 minus 2 is 0 plus 2. So that's 2, but it's times minus 1, so it's minus 2. 3 minus 2 is 5. So we've got our cofactor. Okay. Now, what have you got to do? You've got to transpose your cofactor. What does that mean?
Should the last one there be 1 instead of 5?
This one?
Yeah.
I'm telling you to be careful not making mistakes.
Maybe I've made the mistake.
It should be 5.
Yeah, I think you're right. Sorry. Yeah. Yeah. Okay.
Okay,
All right.
no, that's
Cool.
all right. So what do we do with the cofactor? Well, you go to their address. This is 1, 1, so you swap them. So if this is 1, 1, it becomes 1, 1. It doesn't move. This, however, is 1, 2. So it becomes 2, 1. Moves over here. This one is 1, 3, so it becomes 3, 1. This one here is 2, 1, so it becomes 1, 2. This one here is 2, 2, so it stays at 2, 2. This one here is 2, 3, so it becomes 3, 2. It gets moved down here. Okay, 2, 3 becomes 3, 2. Row and column are being changed. So the transform just means that you take 2, 3, 3, 2. Row, column becomes column, row, but as row, column. Okay, so you just swap the address. So this one here is row, column, 3, 1, so it becomes 1, 3. This is 3, 2, so it becomes 2, 3. And this one here is 3, 3, so it stays. There's 3, 3. Alright, there's one more thing to do. You can tell me what that is. Do you not have to divide by the determinant? Multiply by 1 over det. Is that true? Yes or no?
No.
Well, if you think about the matrix, is that the answer? In here, it's exactly the same. Look. Oh, I've made a mistake there. We better check that one. But 136, what would that be? 36 would be the determinant, wouldn't it? So you know what we can do?
Yeah.
So let's just go here. Instead of doing the inverse, I'll just do det. Tell me the det of that. 36. So it is. We've got to do 1 on det. Okay? So before we can finish, we have to say that the inverse is going to be, that's the final step. Okay? Which is 1 on 36. All of that. And where was my minus 6? I made a mistake. That must have been done up here. Minus times a minus. No, see, I didn't do it. So that's 6. It's minus 6. It is minus 6. So what have I done? I don't know. That's needing to be investigated. Because it's saying it's 3 there. I don't know what I did wrong there. That's saying that's a 3. Did I get the cofactor wrong? I need this one. Did I do that in my head? I think I did. Alright, let's do it one more time. So this is the back T. So if you make a mistake, it's awkward because you're going to spend some time doing it. So this was the back T, wasn't it? Oh, look at that. That's completely wrong. That's just copied that up there. So it's 1, 1, 0 minus 3. Minus 3, yeah, that would be more correct. That would be 3. Dun dun. My bad. See how easy it is to do with the transpose? That was the one I stopped doing it on. I did all the others and then I stopped doing it. The one I stopped doing it on, I made a mistake. Okay, so that's the cofactor method. It's doable, but it's a lot of work. Now, when you do the det, what you have to do is you have to put the row in. Right? So actually you saw what I did with the technology, so that's probably the easiest way to get the det out quickly. Okay, Just remember that all of these, to get these cofactors, we did not multiply by the placeholder. In the determinants, you have to multiply by the placeholder. And you only do one row, not the whole lot. Okay, cofactor is you do the whole lot. Determinant is you just do one row. A row of convenience, if need be. So a row of convenience would be down to get the determinant. So I might just... Okay, so is that alright? Do I need to do the determinant? Are you guys happy with that, guys and gals? Alright, so... we found the inverse by... No, wrong one. We found the inverse by doing the row reduction. Row echelon all the way. We've now done the cofactor method and Cramer's rule then. Okay, so do you want me to do the Cramer's rule one? Yep. Okay. Alright, so for Cramer's rule, we need the determinant. So I'm going to do the determinant just to be completely stubborn. And then it's a fairly straightforward substitution for Cramer's rule. So let me do the determinant. Now I'm going to do it down the column just to show you the flexibility. I could do it across the top row like usual, okay, but I'm just going to go down the row. So there'll be a reason for that. Okay, so for down the row, so I'll have my placeholder, my -1 address, 1 plus 1 is 2, excuse me, and then the submatrix is 3 0 minus 3 6, so I get, that's a positive, so it's just going to be 1 3 6 3 0, that's gone, so the first one is 18. Okay, the next one, of course I'm going down the column, is that one, and I have to take the placeholder, so it's -2 times -1. Now it's row 2 column 1, so it is a minus. Okay, and then I've got my 1 1 minus 3 6, so I get -2, that's a -1, minus times a minus is a plus, so it's 2 1 times 6 so we get -3, 6 minus -3, 6 plus 3, which is 18. So it's another plus 18. So we're going to add those together. Now the final one, it is the bottom corner. So in the determinant, I am multiplying. It's 3 1, so it's 4. But you know what? I don't care because it's multiplied by 0. So all we're doing is adding the two together. And we knew that from the technology. Okay? So we get the det from that. Alright, now for Cramer's rule, it's a pretty easy thing to do. Okay? So generally for Cramer's rule, you've got your setup of your augmented matrix, and then you've got your constants, and all this one does is just substitutes. Okay, we've got det A, so it's going to be A to the -1, 1 over det A, and it's going to be substituted. the determinant, and it's going to be, oh actually I've said A1, I shouldn't have done that. I should have said X1, unknown one, in this case I1, and you substitute the one that you want by putting the constants in the variable column. So you're going to take the determinant of 0, 24, 0, 1, 1, 3, 0, minus 3, 6. So that'll get you x1. x2, which in this case is I2, is 1 over dead A. And this time it'll go into the second one. And finally you'll get x3, which in this case is I3. And you do the determinant for 1, and this time you put the constants in here. Okay, so there's a little bit of work to do. Then you've just got to pick which one to go down to do your determinants. So in this case here it's going to be a lay down Mézières. This one here you're going to do that row, because there'll only be one expression for 24. For this one here you're going to do this one, because there's two of them that are 0, and likewise for this one you'll go across that row. Okay, remember the vertical bars means you're finding the determinant. We've already found the det A, so it's going to be 1 over 36 multiplied by 24 bracket 1, 6 minus 3, 1 minus 3, 6 plus 3, 9. So we're going to have 24 on 36 times 9, so 9 ones 4, 24 on 4 is 6. Have I missed something? Ah, I didn't do the minus 1. Whoops. Minus 1 row 2. Ooh, it's a minus 24. Be careful. Be careful. Okay, don't forget this guy like I just did. Sometimes I could tell you I work it into my brilliant teaching, but that would just be a lie. You might get away with that in high school, but you still get suspicious students. Alright, no, that was a mistake. Alright, so the same thing here. You could go down the middle column here. Okay, but all you're going to do is recognise that why aren't you doing the rest of them? Because they're zeros. So it's plus 0, plus 0. Okay. Alright, so for this one here, the final one is a 6. So it's 1 on 36. Now what's the 3, 3? So that's a positive, so we won't do that. So it'll be 6 outside of 124 minus minus 2, 0. That product means that's gone. So it's just 24. So it's going to be 6, 6, 24 on 6. 24 on 6 is 4. Okay, so that's all you do. There's a little bit of rigmarole in each of them, but hopefully I've been able to make it all a bit simpler for you. Okay, use your technology to check. You can scrub back over the video to see how I put those in, but that should help you study. That's the whole point. Okay, so you're not completely lost. And then finally, for this one here, 1 over 36 minus 3. What's the address of that? 3, 2. Ooh. 3, 2 is an odd, so it's going to be minus 1 times the brackets. 124 minus 2, 0. The back is gone, so it's just 24. Minus times minus is a plus, so it's 24. So it's 24 on 36. Times 3. And just cancel them. 24 on 12. Just 2. And then you're done. Okay. Alright, was that it? Was there any others to do? Anybody? We happy with that?
Yeah, no, that's good.
Alright, we've done a lot, so I mean, I'm happy to keep working if you want me to, but it's more of the same, isn't it? So now you know what the reasons are. You've seen all the examples, just solving a simple set by putting the constants in. So let's just do a quick recap. We might have a look at eigenvectors and eigenvalues in brief next week. Yeah? So a simple set is you put the constants in and you do your operations. And you either do a back substitution. This rebuild here is called back substitution in the textbooks. So there's some point where you can do a rebuild and a back substitution, or you can keep going and just get the values off directly. We saw that multiplication is really about transformation, and a version of that is eigenvectors and eigenvalues. Okay, so that's the next bit. What are these values? What are these transformation matrices, and where does the eigenvalues come in? Then you've got your matrix algebra, which is just helping you work out how to approach the thing, which comes in handy later. And then there's the 3 different types of examples. That's the echelon reduction method, the cofactor method, and then the Cramer's rule method. Okay, and that gets you pretty much to the end. Okay, alright guys, I appreciate you coming along. Thanks very much for coming along, and I'll see you next time.
Thanks, Jason.
No worries. I hope it's all helping.
Yeah, thank you.